Yeah, you're right. So today, as I told you yesterday, we're going to look into CTEs, exercises, and then we look into subqueries, then views and materialized view. These are, I would say, intermediate level. Now you want intermediate level SQL. Now, a lot of things these can do, you can write them using the way we've been writing queries, right? But this helps you for managing your queries when you have longer queries, okay? So we are not going to learn a lot of things that are new. Instead, we are going to learn how to optimize our queries using uh, these things of CTEs, okay? Okay, so we are going to, let me open, we can all open our servers. Okay. Yeah. So I'm going to give you a recap of what a CTE and what a subquery is. I hope you can see my screen. Okay. Can you see my screen? So we're going to look into what a subquery is and what a CTE is, right? As I said, these help you arrange your queries so that they become readable. But in a few words, a subquery is a query, so you can see sub. So you have a main query and you have a query inside that query. So by a query, it in short in short words, you have a select, okay, something from a table, okay, from table, select things from table. Then inside this select, but so from table T, then from that table T, you can also inside that, you can do another select inside the same query. Why is this important? Sometimes you will have so many conditions. Like yesterday, we were seeing a case statement where you have a lot of conditions. So in case you have that, what you do, you just write a query. Then inside that query, you also do another query. Okay, we are going to see in a minute. Then what is a CTE? A CTE is also like a subquery, but a CTE is more readable. Usually it's more readable because now for a query, you have a select statement inside another select statement. But where it differs with the CTE, you define it. You remember how we define it. You use the with keyword. Okay. Then CTE name. Okay. Then as, then you write your query. After writing your query, you can now select from the CTE. You immediately select from the CTE. Okay. So how does this make it more readable from CTE? You select whatever you want. So when you do a select, you sort of have a small table. So you get from your database, you have the table, you get a small table. Then after getting the small table, you now select from that small table. Okay. What is common between a subquery and a CTE? What's common between a subquery and a CTE is they are queried immediately after you write them. You cannot write a CTE and then save it and go and somewhere else you refer to it. No. It does not save it does not save your query on the computer. Okay? If you want to save your query, you use something else that we are going to see later. Okay? So this is the meaning of a CTE. CTE it's called common table expression, then a subquery, which is a query inside another query. Okay? So these are not saved. You don't save. For instance, if the output of your query, your CTE is maybe a smaller table containing, let's say, the average fees per clinic. Okay. So if you have fee average fee per clinic, this is not saved in your on your computer or on your server. No, it's not. So that's why you immediately have to use it. Because after the query, the life cycle of the query, what happens is it will disappear. Okay. Even a subquery. What they help you is making it readable. Okay. Do you understand what a CTE and a subquery is? Yeah. I want to see you. Yeah. Okay, nice. So we're going to look into another aspect called a view versus a materialized view. Okay, so what is a materialized view and what is a view? So now that we know what a CTE, we know that a CTE is for readability and a subquery is also for the readability. A view and a materialized view, for them, what they do, you also have long queries, but you need to save some data, some queries, not data. So when you want to save them, you use what we call a materialized view. Okay? Materialized view. It's like a table you get from your queries. Okay? So once you declare it as a materialized view, you get, as a result, you get, when you do a query and you get a table from that query, that table is what happens to that table? It is saved on your server as a new table. It's saved on disk. So what it means, you can come and query it like a new table. However, what happens is whenever you query it, it's not like a normal table, like normal. Someone has a question? If you have a question, please just speak. I won't be looking into who is raising their hands. So what happens is, if I want, now I've saved it. Tomorrow I come, I want to query this table. What happens is when I do select from this table I created of materialized view, which was made, which was generated by a query I wrote here, okay? What it does, it doesn't query exactly this table. It's this, actually, this is like a logical order. But once you query it, it comes back and reruns the same query and then reproduces the same table. Okay? It's not like it's a fixed table. Okay? So that's why if you're a data analyst, and data always, as we say, has big data. For instance, if you're dealing with big data that comes in large volumes, okay, it's in high volumes and in high speed or velocity. That means it may becomes daily. So what you do, you need to update your materialized views. Once you update it is by selecting it, you are updating it. So what you do, once you select, it again reruns the same query from your database, then builds a new table. So yesterday, if you had 5 clinics in this table, okay, once you run today, and maybe new clinics were registered, new 3 clinics were registered today. If you select from this materialized view, it will run the same query from the database, then it returns 8 tables. You get? So this is the logical order. Now, what is a view? A view also saves it, but it does not save it on the disk. For it, it is more logical than a materialized view. So a view is not saved on your server. Okay. For it, it is saved. It is like a CTE or a subquery, but the difference is it's also a table, but I can say it's an imaginary table or logical table. Okay, because it is not stored exactly on your server. It's just like a table, but you cannot it is not saved on the server, while a materialized view is saved. So why is this important? It is important to know this because you know where to use a materialized view and a view. Okay, how? For instance, you can understand that if it's saved on your server, this materialized view will take space on your server. It will consume your server. If you write a materialized view that have 2 GB, it is consuming your memory, your server. Okay? It is consuming your server, right? But for this one, it is inside the server it is inside the query. It does not consume it. So, but this one also is faster to query, a materialized view. Okay? If you're querying same big tables, this one, and you're using you wrote a materialized view. If you select from this materialized view, of course, it will run on this, but it already has some data. It will add the new data that was not here, and then you are able to query it faster than a view. So this means it consumes your memory, but again, it is faster to query. So the same table here can take like 2 seconds, while maybe this takes like 3 seconds or 4 seconds. Okay, so you need to know what to use and when to use it. So let's do maybe an example here. By doing a quick search, we say difference between view and materialized view. You can search from the internet. Okay, let's see what a standard view is. So it's a virtual table, right? And stores only a query definition and fetches data dynamically, whereas a materialized view physically caches pre-computed query results on disk like a real table. This is the difference. That means once you declare a materialized view, it physically stores. That is the caching they are saying. So the pre-computed query result on disk that is on your server or on your local machine if you're using the local server. Okay? So that means if you save it, it takes space. Okay? So let's see some differences. Here on data storage, a standard view or view only, it, it is virtual and does not consume disk space. It does not consume your server. This is physical. That means it saves data directly on disk. Okay? Then query speed. This is slower because it executes the underlying query every time it's called. So this is slow, although it does not consume memory space on your computer. This is faster because it reads pre-calculated data instantly from your computer. Okay? Data freshness. A view is always in real time and up to date with the base table, the other table you're querying from. But a materialized view, because it's already saved, it can become stale. So it requires manual or scheduled refresh. You can refresh, okay? So indexing, let's not leave let's leave this. Okay, the indexing part is a bit more advanced. So basically, for them, let me share one of the sources here. Okay. Yeah, this is nice. This is a good one. So do we understand the difference between a view and a materialized view? Do we, for now? Sorry. Do you understand what a view is? So this is logical or virtual. It is a virtual table. Okay. Do we understand this? Do we? You-
Yes,
you
we do.
know, Okay. So when we go to writing queries, you'll be understanding what is exactly happening, right?
Right.
Yeah. So by the way, I think if we get time in this session, I want us to look into, because we can say we are now data analysts, right? Aren't we data analysts? Maybe we need more Python and practice, right? So I will take you through, it's not like something that we've prepared on the course, but it's important to know about storage, computer storage. If I say disk, do you understand what the disk means and what is the implication on a computer? Does anyone understand if we say memory? Okay? If we say cache, when you are caching, when you say caching, when you go on a website and they say accept cookies, do you know what that means? Or when they say cache data, okay? When they say RAM, because all these things affect our servers. When we say a server, do we know what a server is? Okay. So I hope I will reserve a few minutes after this session to take you through, because you need to understand what is happening when you're dealing with the database. Okay, so before that, yeah, that's a bonus part, right? So for now, let's let's go to our today's push-ups. It's here. So this is basically, I didn't want to stress you, so I also included the codes, right? So who can share their screen as usual? I don't want to run all this. I've already run it on my computer. Okay. Who is, let me again run it. Who is ready to run all this on the computer? Anyone? A volunteer?
I can do it.
Okay. Now that she's the only one that volunteers. Okay, it's okay. You can please, teach us views, CTEs, and seeing the differences between these CTEs and what we've been looking in the last sessions. Okay, over to you. Okay,
Someone is.
Nawana, do you have a question or you want to share your screen?
No, let Collect go ahead. I was just telling her that when she's through with it, I may be able to share also.
Okay, yeah. Yeah, we need to collaborate, yeah. Okay, over to you, Colette.
Thank you. So I have to switch the computer again. Sorry for like 1 minute. I was using 2 machines. Now, can you see my screen? I don't know if it's visible. Okay, so we have the preview, okay, or the task paper. So can start. So we can start a query, a new query. So again, we are in the same database. So I'm going to run the codes and we will review the result. Okay, so we have we start with subqueries. Before I start, then is the goal to explain, or we can share the conversation from the result or what?
Yeah, explain now, because for instance, you're showing the name and population, the average. So what are you trying to do? Because it can be done with our ordinary queries, right? Without adding a subquery. So what are you trying to do? Explain the query
Okay, so I
and
think
what are
we
you
are
using?
going to show the difference between the subqueries and the advantage of using the city. If we run, for instance, if we start with subqueries and also look at how this can be a little bit simplified with city queries, it will be, I guess, understandable. So this is a subquery, and it's a subquery because here we have the main query, the first is select, here where we select name and population from countries. And within this query, we also have another query where we will be selecting the average, population average, and also from the same table countries. So it is a subquery because we have this is this query inside the main. But as for it's just an example of a subquery. Then the exercise, okay, the exercise was to find what was it? Find the countries whose life expectancy is above the average. Okay, so is this the exercise we are going to do?
Yes, try now. Doing that. Find countries whose life expectancy is above the average.
Above the
So so that means you first find the average, now know the average, then do a subquery that gets those countries.
use, okay, with subqueries.
Yeah, with subqueries.
Okay, so find the countries with average. Okay, so okay. I'm sorry again, from country. What do we have? Actually, I didn't looked at this country's table. Okay, maybe just a few of them. Life expectancy. Okay. Life expectancy. So, guys, are we together here? We can do it in a team. So we need. So find the countries. So we need the country names. Or we can use the same query here. We can
It's okay.
adjust. So with.
But we just need the name of the country.
It's
right?
just name. We select name.
And their life expectancy. Then you check you just get which ones are above average.
Life expectancy. Life expectancy. So We select from the country, This is me. Countries. We put the condition. So the condition is
use, okay, no
life
worries.
expectancy. So life, okay. I'm using the above query. So we have life expectancy, which is there, which will be greater than, it's above. So I'm going to carry, now we need the average of the life expectancy. So we say the average. So we select. We select average. Life expectancy. Is this computing it? I just wanna check it. Is it closed? Find the countries. But what was the life okay. What was this average actually?
Of the life expectancy.
I mean the average, because I'm seeing the number and I don't know what the average is.
Nice.
But can I, without grouping? How can I?
No, you don't need, do you need to do the average expectancy?
No. I believe it is below these numbers. So
Yeah, exactly. So if you want to show it, just select that, select the internal select and use it as a single query.
here.
Yeah, on a side, copy it and paste it somewhere.
Oh, okay.
So you can see that's why they are advanced. It assumes you are sure that that shows the average life expectancy.
Can I do this? Like
From countries, yeah. Now, yeah. So now if you see
66.
6.24.
Okay, yeah. 66.2. Okay, so these are above.
Yeah, they are all above. So
Yeah.
if you do less than, we see.
So these are Ethiopia, Kenya, and Rwanda are the three countries with life expectancy above the average.
Check below.
Below the average. So below we have Tanzania and Uganda.
Okay.
Okay, so this is a subquery. And we understand that it's a subquery. We have to select one inner and the outer on the main query. Select.
Yeah. Okay. For instance, try to write it without using a subquery. Like usually how you would write a query to show which countries have a life expectancy above average.
Okay, a normal query with one select. Which countries? So I need the name. I need the name. And life expectancy. Okay. Country. The form average. Oh, okay. So
Your head is already in subqueries. Yeah?
I don't want the second select, so I can type the life expectancy.
You've forgotten where. Eh? Okay, you okay. Okay, continue. See,
Where
subquery.
comes after from? Okay. So select name and life expectancy from countries where how to calculate? Can I put like I wanted the average without select?
Yeah, try. Just do where life expectancy, average life expectancy. No, average.
Where average
Hey, no, where life expectancy
is
is greater.
greater than average. If I say average life expectancy, I
Yeah,
need to calculate. Okay, average.
do
I
that. We
need,
see what happens.
does it calculate this without select? Invalid.
Hey, group, invalid group. The average. Yeah. Now you can see it's very tricky without.
Select. Without subquery, it's I don't know how to do. Usually the average can, or I can just put the. It needs a formula or what?
Can we do the sum? Sum divided by.
Sum divide. Maybe that one will work. So I take life expectancy divide by the sum of what?
The sum of life expectancy.
Life expectancy sum.
The sum of life expectancy. No, the sum of life expectancy divided by the number of.
Sorry,
Okay.
this is not going to.
No, the sum of life expectancy.
It's here.
No, the formula is the sum of life expectancy divided by
Oh,
the number of rows.
okay.
Normally, the average is the sum of variables divided by the number of variables. But I don't know if we can
You are
find.
right. Sum of life expectancy divided by the number. So I count.
Yeah. Star.
What do we count? The country. Count or from country.
Star. Yeah.
How do we write this?
Yeah. Let's try.
Count or from country.
Let's try this.
You see how it's tricky?
Why? We don't. Most of the time, we don't even understand these error messages. We know that it's not correct, but it's not directing us to understand
You know what invalid use of group function is?
Not really.
Every time you run a function like that, sum or average, you need to
Yes.
do group by.
A group by. Oh, so a group by. Okay. You can add that, maybe.
But still, you remember the order of execution. Group by is executed before where? Okay, try. It won't, try and you see the error they give.
Okay, group by the countries. Or what? Name of country. I don't need it. Let's group by the name.
Invalid use of group function still. Because, okay, now first do a group by name. Although still it's tough.
But the formula is correct.
Well, if it's correct, to be working.
Okay, so we wanted to, life expectancy over some of this.
Now you see why subqueries are important. Guess what? If you were to write it using normal queries, I'm going to give you a script.
Yes.
I'm going to run called
this?
self-join. Let me share it here. Now run that and see. See why you must, so the order, what it takes to follow the order of execution without using the subgroup. I'm coming.
Where is that query you sent? Oh, okay, it's here. Okay, so we have
Run it.
Okay, I run this. Oh wow.
You see what you need to do? You would have to take one table as two different tables and you join it. It's called self-join. You see, from countries, join countries on 1 equal to 1, like it's literally the same table. So that's where you can do a group by having all those other functions.
Oh.
So this would be a very long query, right?
So this is the only way.
Yeah, other ways you need to use TTE or what we call window functions. They are very advanced, but see how a subquery just does it.
Okay, yes.
Now try to use a CTE even before you go to the next exercise. Yeah, you see how simple it is compared to this long ordinary use. So you can see this is a long query. Eh?
Yes, it is. Okay.
Now try to use a CTE, which is almost the same like a subquery.
Where to insert the CTE?
After the subquery.
After the subquery?
Yeah.
You mean in this first one?
Yeah, between that subquery and that longer query.
Okay, let's see here. Between.
Now go up. No, it's okay. On line 28.
So I started from here. Let's call it maybe expecting. Let's call it expectancy. Good.
Then first select the life. So what do we select first?
We need the life expectancy.
Think about it. What do we need first?
We need the name.
Really? Okay, you see, it will be different difficult. We need to first get the average, then after that we select from countries where average is above the output
Oh,
PE. If you first find the countries, you need to find average, which is causing us all those problems.
select, yeah, average of life expectancy. We also, okay, it's from countries.
Yeah, so that
Yes.
is the CTE.
Okay.
To select, you need to also have
So,
what is the output of select average life expectancy from countries.
let's see.
It's okay, you can also give it an alias so that we know what average life expectancy as average life expectancy maybe.
As average life expectancy. Okay, so we have this. Will this work? Oh
You
no.
said you're a
Sorry,
mathematician,
sorry.
eh? You're going to use your math logic.
Oh, okay, so with this, okay, then we select.
Okay, select all from the CTE. We see what happens. What's the output of the CTE?
Life expectancy. Why is it blue now? Okay, so what do we have? Okay, we have the average. Okay.
We have the average. Now, how do you distribute it to the other?
Queries. You need for other to check whether each country to compare the life expectancy with this average. Okay, so we have a select. I need now name and life expectancy. Life expectancy. No, I put the condition. Okay, from we need from countries. Now where? How do I refer? Okay, where? Life expectancy. Okay, so is it greater than? I don't want it to rewrite this again. So I select this. This is greater than this.
No. So how would you combine? You see how they are advanced, but when you use them directly, it's just okay. So
Yes. How do we refer? How
from
do we
countries,
use it? Okay, for all countries.
how would you distribute the average on all those tables? How do you think of anything? Do you know Cartesian product in math?
Cartesian product. Yeah.
You can Google search and see how it works. Natwe tubirebe.
Cartesian.
What is Cartesian product?
Yeah.
So you see, is an operation.
Yes.
Imagine you're ordering a meal and have these options: set A, set B, burger, pizza, soda, juice. Cartesian product create a menu for every possible meal combo. You get burger and soda, burger and juice, pizza and soda, pizza and juice.
Yes, yes.
If you had soda only
Soda only.
as drinks, what
Yes.
you do, you do get burger and soda, pizza and
Pizza
soda.
and soda. Yes.
If take burger as country, pizza as country, soda as average, what
Yes.
would you get? You'd get burger and average, pizza and average, right?
Yes.
And you get a table of pizza, burger with where average is everywhere. Then you select where average is above that average, where life expectancy is above average. You get the analogy.
Okay.
So what we are going to do, you see, it's complicated, but go back to the SQL, to the query, then do cross join. That is the Cartesian project. So you selected count
I
name
selected.
expectancy, okay, from countries. Then first join, no, before where? Do cross join. So you're doing a Cartesian product.
I join.
Cross join. So there's another join I
Oh,
didn't want us to
it's
cover.
called cross.
Yeah.
Cross join.
A cross join, I didn't want us to cover it because it's the math part of data analysis.
Okay.
It does a Cartesian product. So cross join what? No, you just
Life
do life
expectancy.
average life expectancy, the average. So what we are doing is we get the countries and the life expectancy, and we populate the average life expectancy on every country, just like the Cartesian product. Now close.
Or I type the formula like this.
No. You have the
I
align.
called it average. Did I use the name or
The
just
name.
the name?
Yeah,
Okay.
that's the use of a CTE. Now remove the where, you see what happens with the cross join.
Cross join. Okay, good.
I told you we are in advanced SQL. No, it should be, don't close the CTE. Don't close the CTE. And also, you're not selecting from countries, are you? You're selecting
From life expectancy.
expectancy.
Life expectancy.
Oh, no, really. Select them.
Um,
No, you're selecting from countries.
From countries.
Instead, you're joining with life expectancy table. Yeah, join the life expectancy table, not the average.
Okay.
X what's in the life expectancy.
Yeah, life. Now it is more. It has more expectancy.
Yeah.
Join on what? Just like this.
No, it's just you don't need keys because it crosses all over everything.
Okay.
Now close.
But it seems like I am having two different queries.
Yeah, you need to remove the first query. Select from all from.
This one.
Yeah.
Oh, okay.
Close and run. You see now?
Great.
Or you need to also add average life expectancy, which is coming from life expectancy.
I can put it here. Okay, yeah, average. Okay, average. Life expectancy. Oh, sorry. I just put.
No, you use the name.
I already have it. Yes, I
Yeah,
called it average life expectancy.
Yeah.
I thought I used it for.
Now you see,
This is a great.
you have done a cross product and you have populated it all over the place, right?
Okay.
Now you can do your filter.
Now can you filter?
These are heavy push-ups, eh?
They are really, yes. So filter. Which one comes first?
So
Okay.
where do you want to consider? So you have the table.
Yes. I want only the
Where
countries
the life expectancy is.
life expectancy is greater than the average.
Okay.
Okay, having to avoid it.
Really?
Having life.
Did you do a group by?
No. But cross is okay. Cross join is not there. If I
Yes,
do where okay, where life expectancy is greater than average. Life expectancy. Select a country.
you see. Now you still have the average life expectancy. You can just remove it from the columns you're selecting. It will give you exactly what you needed.
Yes. Oh, but this is a good. Oh, guys.
You see,
Okay,
when they
so
become heavy, eh? You learn a lot of things by doing
yes.
one. If you read it, you would think it's a very simple question. But as you can see,
Okay.
which approach do you prefer to use?
This is good.
Subqueries.
Subqueries is it? Okay, because it seems here it seems shorter. Maybe it depends on the question, but this is great. I like
Okay, now
this because if you want like this to check which like
yeah, to
what
know
was the
exactly what's happening.
just 1 second. Okay. Okay, so yeah, this is great. I like it. But cross join, we are learning many things. Any question?
Can you run again the second one? Then,
The second,
yeah,
this one,
yeah.
or the first one?
This one, this one.
This one. It's the output here.
Um, I, I, I just wanted to check the number of millisecond, but apparently this one is
Oh,
not.
yeah. That's a very good. Who is asking that question?
It's me. It's me who asked because
That's a very good question, by the way. Can you ask it again?
okay. My question is simple because sometimes we have two queries doing the same thing, but there is what we call a query optimization, which means writing a query that is executed faster than the other. So sometimes the speed is also very important to in writing a query. Yeah. So apparently this second one, even if it's complex, but it's faster than the
Okay, run
one.
the subquery. We see that the millisecond it takes. These are 12 milliseconds.
But they are also fast. It's also 7 milliseconds. This is even more. It takes more.
Because you do a cross join. You know, joins take a lot of time. And if
Yes.
it's a bigger table, it would increase exponentially. So can you write on before with, write the word explain.
The word?
No, in front of with.
Yes.
Okay, explain.
Explain.
Yeah. Then write, okay, yeah. Then run the query.
Explain.
Let's see, near line. Okay. Here at with down, tab down, run. Oh, it's
Do it. Do this. Oh,
It's
now I
it's,
see.
it's separated like two queries. You have to combine them.
So how do we
yeah.
combine them?
After with,
We will do.
I think
This is from.
no, that should work. I don't know. Remove it and we see whether your query runs.
Sorry, I
Just
remove
remove it.
explain.
Yeah. It runs.
It runs 5 milliseconds. Oh, it's even 5. Okay. Yeah, it runs, but explain why does it divide into 2 tables now?
Has it given you the out the
If I put explain, it has divided the query into
I
2.
don't know why, but can you search explain in SQL?
Yes. The
It
center.
shows you the execution plan. So it shows you what's actually happening with your query to know to understand your query performance, right? Because yeah, that would should work. I
It's
don't know.
from there is no to explain.
You can read about it. It just show you the query, what is happening with your query.
Okay, so
I don't know why it's
Maybe it's because of space. What is
there is no.
you can read about it. Everyone can read about.
Oh yeah, yes. It was true. It was there was a space between the two, like this. Yes. Thank you, Daniela. So now we have the output. What is it happening now?
So
This is the output.
partitions, no partition system. So the ID you're joining all. So you did the join, primary table derived countries, using countries, partitions, type. You can read about it, just shows you the execution plan of your query. You can read about the output of the explain word, but I believe it usually even shows you the flow. I don't know why it's not showing us, but it shows the flow of your query.
The flow.
Like it comes from join and then cross join, then filter, then from, then select, you know. That's what I expected. Yeah, but it's okay. You can read through the explain keyword. It just shows you the execution plan for your queries.
Let's see this summarize. I don't see anything else.
The cost, yeah, it shows you the cost. Yeah, that's actually. Can you scroll? Because it shows
I
how
don't.
much you've used analyze.
Oh, okay, there is. Oh, this is the wrong.
Yeah, this is what I wanted. It shows you
What
the
cost?
cost. The
Oh, this you mean?
Yeah, the cost. I think cost.
Gross. Is it the time it takes? What is cost? Does cost mean?
No, it's how can I explain it? So what it takes for the database to execute that to perform that query. It's not
Okay.
like it's not the time.
Okay, yeah, the actual time it's shown. Okay, so it's here.
So that helps you understand because they've asked about the time. It helps you now have in your head that when you're writing queries, you need to optimize them,
Yes,
especially when you're dealing with big tables. Okay,
yes. Yeah.
nice. Let's just go. Okay, it's 7:30, but we started a bit late. We're going to take a pause at 7:40. So go to the other part of
Question.
cities.
Okay,
Yeah.
okay, good. We have.
If you're not following along, you will get lost, to be honest.
That's the thing. We are not. Is anybody? Is there anybody who has a question? Otherwise, well.
Someone was ready to share. Was it
Janab.
Gaia or Janab?
Janab. Yes, he will take over, I think.
Let him take over after the break. You can do the second.
Okay.
Then you
So,
explain that CTE. Then he starts with the exercise.
okay, good. So create a temporary name. Okay. This is also quite interesting.
We are now expert SQL users.
Yeah. Oh, I thought it was a question. So this code, okay, let's first run it and see what it gives. Total number of visits per clinic.
Yeah.
This is a subquery.
Well, is it a subquery?
No, I wanted to check if, okay, it's a city.
And by the way, you can mix subqueries into CTEs, you know?
Okay, yeah. So because we are a bit confused, in mind we kept in mind that subqueries we have this select inside the other select, but I see this is a different story.
You are selecting from where?
Here it's from visit, here it's from clinic. They are different.
There are
Yes.
two tables.
Yes, I see. So the question, what were we calculating? Sorry again. Don't want people to get confused. Oh no.
No, you can check from the
Okay.
output and
It
tell.
was the total number of visits per clinic. Total number of visits per clinic. So we from the visit.
Give me a minute. You can continue explaining. I'll be coming.
Yes. So we are interested in the total number of visits per clinic. So we start by selecting the clinic ID and also for each clinic ID, how many visits were registered. And we group by a clinic ID. This is one, just a simple query to calculate the total number. Let's see how this CTE was actually used to access. Do you know why we make this join? Why we made this join here? To know, to calculate the total number of visits, we need, okay, the number of visits, they are from visit table. But to know the exact what clinic was visited, we also needed to know, to look at the clinic table. So that's why we have to join these two tables. And here we had, actually it's an inner join, simply join. Summary. Okay. In a normal way, how would we actually work on this? What do you think about this query? Is it longer or short? To me, it seems like it's a bit longer in this case for this short or small question. What do you think, guys? Because we need information from two tables. We need a join. We need to join this the clinic and visit tables. In the join clause, we are actually using the city instead of using the normal.
Yeah. Can you maybe write it the way you would write it
In a
without
simple, to me,
Yeah.
I was thinking the normal way is much it's simpler.
It's
Okay,
okay, write it
so
and we see. We also check what happens.
the total number of visits. So we need the clinic first. We need the clinic name. It was a name. And also total visit. Okay. Per clinic. Total visit. I need the count. We need to count the visit. Visit was we need maybe total visit. So number of visit. We have this. We will count, but we need we join. We are from select from. We needed the clinic, so clinic to be from clinics. we join in a normal way. I do the left join, like yes, we did this yesterday. We join visit. We join visit to clinic. We join on was clinic ID was clinic. Okay, I think it was this from clinics. We join something like this. Okay, see name. Is it aggregation? Oh, sorry,
Group by.
this aggregator you always go. Group by name. Okay, so I bring this. So I made the wrong. Okay, I don't know actually what to hear was the question. If
Let's
to
find the
avoid
number of
maybe,
visits
yeah.
per clinic.
Okay, so was this in a normal way, but it takes.
Okay, run it.
Yeah,
that's the
it
you want
takes
to.
longer.
Yeah.
38. Oh no. 10.
Again, run it.
Every time I click, it's a different. Okay, around 10.
Okay, run the other one.
And this just 9. It depends on how many I click, how many times.
Usually the CTE has already, so that part, maybe it's because you're doing the joining, which is the heaviest.
The
After,
join, yes,
yeah, but the CTE
is
stores that
faster.
it should be.
It should be faster. Okay. Yes.
Nice.
Okay.
So
I think
let's
that.
take a break for 10 minutes. We will come back with Janab sharing his screen and doing the exercise.
Okay. Thank you very much.
Thank you, Colette. Thank you.
You are most welcome. So I should stop. Do you want me to copy? But we have this, or I can just paste before I go.
We are back. We are back. Jonap, over to you.
Okay, let me share. So we're looking at the city. I hope everyone is seeing my screen. Is everyone seeing my screen?
Yes, we can see it.
Yes, we can.
Yes, yes. So, uh, my sister Coletta just shown us how to explain to us how city is created. We had an example here above about the clinics, and we wanted to know. Here, I think, let me try to run it. So, we're trying to know the total visits per clinic. So, they had used to the city function that uses with as the attribute of the other table that we want. So they just joined the two tables. So let's say about this exercise. Create a city named visit clinics that returns clinic ID, visit count, and average fee. So they say to name it the visit, to name the city clinic visits. Let's start from there. I'm sorry, I still use AI. Okay, so sorry. I
No
remember.
problem. Oh, okay.
Sorry. We start with. So they say that the we'll name it clinic visits, right? Uh-huh. And this will be as put in brackets. First, they say that must return clinic ID. So select, right? Select clinic ID. Clinic ID. Then we count the number of visits. You count the number of visits, average fees, per visit. I think these are from the visits table, right? The visits table. Yeah, we have to count because we have used the count function. We have to remember to we have to use group by, but before we use it, I think we have to join something because clinic ID isn't in the front from visits. Let us delete. Let us close it. and do another select. No. Select the what else? Clinic ID. Let me see. Okay. What if we join here? If we join, yes, because the clinic ID isn't in the visits column, so you have to join them. Clinic ID equals to the visits clinic ID. That's true. Let's see. Maybe we'll group by then that count of the visit. Group by the clinic ID again with the visit count. Let me see. Yes.
From visit, just the nickname V.
From again, please.
From visit,
From visits.
the nickname V.
Okay.
And also the parentheses.
We remove them.
No, don't. The clause will be at the end.
Okay.
Yeah, we're still in the same.
Like this, I think. Okay, let's run it.
Specify which clinic, the clinic ID from which table. Is it V or C? Select clinic
Okay. That's true. We select. We select what then?
I mean, after we've the first select, the clinic ID is from visit v.clinic ID.
We.
Above. Yes.
You mean? I didn't hear you well.
Above.
Above what? I didn't hear you well. Can you?
Yes, I mean the second on row 30.
Okay.
Yes. V.clinic ID. Because to specify where that column is coming from.
That clinic ID.
Yes. It's from visit table.
So we
clinic ID.
Okay.
Yes.
Like this.
Yes. Small V, not capital V.
That's true. Run it and see. Let me see. What happened here?
Cross. Oh, okay. We don't run it. We select from that clinic visit. Another line.
Another select.
Yes. Select. Select all from clinic visits. All.
All.
From
Okay,
visits.
that's true. I think you have a clicks ID table, the visit count, and the average fees. That's pretty good. Yeah. So if anyone wants clarification, he might tell us, and then we could. If not, we might continue. So let's continue. So after this exercise, we have what? We have another using multiple cities. Let me paste all this. This is an example of using multiple cities. So here, what do they want? Clinic visits, district visits. Let me see. Districts with the total visits. Oh, they wanted to know the total visits within the districts. So they had used the multiple cities. So they selected clinic visits, clinic ID count as visits from visits grouped by the clinic ID. Okay. With the district's visits as we select the clinic districts and we summed up the clinic visits. Okay. From the clinic's table, joining the clinic visits with visits in the clinic ID grouped by the clinic district. We selected from the district visits. Okay. I think that is it. So, Mr. Dan, can you continue with the views or?
Yeah, you can continue from with the views. Oh, I didn't show you the syntax for creating a view, but you can basically use that because it's almost like a CTE. You just, instead of with, you do create view. And
Okay.
that's it.
And you mentioned the view doesn't store, it isn't stored in your disk, on your disk, right?
Yeah. It just creates a virtual table, but it's not stored.
Okay. Let's copy this example as a reference. So, I want to create a view of the clinic's visit summary, whereby it includes the count of the visit ID as the total visits from the clinic column, Join the visits column. Yes, with the we group by the clinic's name. Okay.
Yeah, you can see for it creates something and stores it, okay?
So where
So you
can I
don't
see
need
that
to
it is stored somewhere?
it's not stored on your disk, it's just a query that is stored as a virtual table. So the way to query it, just do select all from clinic visit table. Clinic visit summary, sorry.
Yeah. So like this table is virtually stored now.
Yeah.
You cannot see it somewhere. Maybe it isn't shown somewhere.
Yeah, it's not shown.
Confirm. Okay. Let's do an exercise.
Then I have a question here on this virtual view. If, for instance, I close this SQL session and I reopen, do I have to recreate it again, or I can record it without?
Good question.
Or if I open a new query, can I refer to this if I'm still inside the same database?
No, you don't. You can't. However, if you write something like a new query after that,
After this, oh, it's
after
the
this, you can later refer to it, even not immediately trying to access it.
okay. Okay. Thank you.
So it cannot be. It vanishes as the other cities.
Yeah, but for CTE, you need to immediately query it.
Okay. But for this, you might not do that.
So for
Sorry?
this view, if for instance we start a new query down, we can record this. We can still use this view. It's different from the city. The city is immediate in the same query, but this can be recorded. Thinking that the next one we will see how it is important.
Exactly. So try to query it clinic visit summary. Then query, it already exists. You can see table already exists. But you can't see it. It's like you're creating a table, but query it says select all from clinic visit summary. It's exact, yeah, it's total visits. Now, can you query the visits table? Select all from visits. No, you can leave that one.
We need this now.
Yeah, write a new query.
Select.
All from visits. Just like that. Run. Now we can see how many visits. We are going to add.
Let me run it from.
No, we have. I want us to change. So because it gives us a visit summary, clinic ID, which clinic is. Okay, do count, select count all from visits.
Select count all.
Yeah, from visits. Really, no, I want to count how many visits per minute. We have 12 visits. Now we are going to update the visits. No, not really. Let's update the clinics table. Select all from clinics. We are going to add a new clinic.
Sorry. From
Clinics. Yeah. So go down, add the new clinic. Down.
Say
Say
add.
alter table.
Add.
Alter AL. No. AL
Alter.
table clinics. Let's remove. Do we add or maybe in clinics? Let's remove. Which one is one? Let's check ID one. Kachiru Health Center. Remove that one. Do job Manuka.
Okay.
Then is it drop or remove? Do remove we see. Remove column. Oh, it's a row.
So
So drop. Drop. Row. How do we drop a row now? No, there is.
row ID.
Let me check. I've forgotten how to drop a row in SQL. Oh yeah, it's delete. Okay, it's okay. Delete. Yeah, start a new query. Delete the alter table thingy. So when you want to delete from clinics where ID equal to 1, the Kachiru Health Center. 1. Now, before running this, 1, close. Before running this, go again in our view and run it. You see?
In our view.
Yeah. Select all from clinic visit summary. This one. Okay. You can see we have Kachiru Health Center. Okay. 3 total visits. And it is 1. Okay. It has ID 1. Now we are going to delete it from the clinics table. Go down and run. Cannot delete or foreign key constraint fails. Cannot delete or update foreign. Yeah. You cannot delete it if you have already joined it with another table. That's the reason.
Okay.
Okay. Yeah, it's okay. It's okay. I wanted to show you. So if we had not joined, you can see SQL is very smart. If it's joining with other tables, it does not allow you to delete such a row. But if we had the view, okay?
Yes.
If we had the view and it does not have join, right?
Yes.
So we would, if we deleted one row and again run the view, it would not be updated. That's what I wanted to show you.
It would stayed the same as
The
the
same.
previous.
It needs a refresh. That's one of the disadvantages of views or materialized views. Because it's already a table, if something changes, you need to again refresh it.
Can you
But there's a way
refresh?
of refreshing.
Can you refresh
There's a
the
way.
view, or you refresh only the materialized view?
That's what I want to, because for materialized view, that's for sure possible. No, you do not refresh it because yeah, you're right. It's a virtual. You do refresh materialized view, but not the view. Okay, yeah, let's continue. It's fine.
Okay, okay. It exists. So let's see an example here.
Of a materialized view.
Yes. So that was the view. So let's see about materialized view. Let me copy it. So this is an example of the.
Mm-hmm.
So
So you can just change create materialized view instead of view. Yeah.
just it adds that this materialized only.
Yeah.
Okay.
So you are going to see the difference.
So this was the. Let me see. Let me run it again.
It's not created. Just click on that arrow to confirm the edit.
This one.
Now run. Oh, it's called, okay, change. Maybe click visit summary. MV, materialized view.
Near material.
Create materialized view.
I added this MV.
No, it's okay. It shouldn't. Near materialized view, clinic visit summary. As. Remove as. Let's see. Yeah. Regular view. Yeah, I see no. Go back to, so you name it. That's exactly how.
So this was the view that I had created.
Mm-hmm.
They are saying
No, don't, no, don't accept that. Create materialized view. Why is it not working? Put it in AI, we see why it's not working. The materialized view, because the syntax is correct. Maybe we're missing something.
Maybe.
Is it working? Now it should be working. Why? You can
Yeah,
see it's working.
it's working, I think.
Copy that. Copy. But
Let
no.
me. Let me copy the error.
Mhm. Can you copy it?
Except what?
Remove the ID. I am. Okay, let's try to create a new. Okay, can you check the example that you are given in the exercise?
Mm, yeah, we hadn't put the materialized view here.
Let me check.
Maybe we shouldn't put materialized. It will be the same as the other one.
Okay, do instead of materialized view, do create table. But that's weird. Do create table.
I remove this.
Yeah, but that's weird. Right? Table, run. Query, try to query it. Select all. Now let's see clinic visit summary. Go to your tables in your database.
Mm.
Look for tables. We see if it's written on disk. The database you're using. Tables, clinic visits, it's there.
Yeah,
You
it's
see,
there.
it
Yeah,
creates, yeah,
and
it
that's
creates, oh, interesting. Why is it not accepting materialized? Oh, it's just used in Postgres. Let me check. I'm just wondering why. Can you run this query? Why it's not working there? Oh, no. It won't work.
I leave it.
Select clinic ID. No, it works. It should work. It should work.
Let me take it and see.
Check it and see.
So substitute or I do another?
Another one. A new one.
Okay.
Run.
Create a materialized view. Okay. They're giving us the same error.
That's weird.
That's very weird. I'm not sure.
Let me see on my end because
Let me select this one and put it in ChatGPT.
I think maybe if it works, maybe you have a different version because
no,
it says that my SQL doesn't support actually that syntax. It doesn't support the syntax. Okay, create materialized view.
Oh, that's what Colette was saying is true. They're saying the error is not the SQL syntax. Is that my database does not support the create materialized view.
let me check the type of database that we have. Oh yeah. True.
I think they're giving
That
us.
works. Yeah. Oh, that's the reason.
I think they're giving us PostgreSQL or Oracle. That's the problem. Daniela, please mute.
Yeah, hello. Yeah, that's the reason. So instead of doing materialized view, you can use table, create a materialized view, something like a materialized view, but it's a table. Just replace materialized view with table, but with having in mind that materialized views do work on Postgres and Oracle, yeah. More advanced databases. So this one, the problem is we're running SQLite because it's on our local server. Yeah, you see, you can see it's not like the way we usually create tables. It's okay. Can you go back to the exercise? We want to leave time for the quiz. Yeah, that's basically the summary. You did not open it well. That's why it's chaotic. It's okay. That was the summary. If you want to open it well, just right click the file and open preview. No. Where are you opened it from? Okay, open preview. It's there. Open preview. Yeah. So that is the summary. Subquery. A subquery stores data? No. CTE? No. A view? No, because it's a virtual table, but a materialized view stores the data as a table. Is it reusable? No. CTE, it's used inside that query. A view is used, and the materialized view. Auto updates, the first one, yes, but materialized views, because it's a table, no, you need to refresh it. Okay, let's take 5 minutes or maybe 3 minutes. I want us to leave enough time for the quiz, which is the final thing. So I'm going to talk you through storage because it's very important. Someone was asking how long a query takes or where do those things go. So first of all, okay, let me do this. What do you think happens, for instance, when you're writing these queries or on the database? So first of all, what is a server? Can someone tell me what a server is? We had talked about it a little bit when we started. Now we are ending with it. Can someone tell us what they know about? Anyone? 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 No one can tell us anything about servers. What they know.
But I think for me, they are storages, but bigger than our usual. Maybe it depends. But computer-based storages.
Yeah. So I'm going to tell you, this is just in words. You will go and I'm just going to tell you theory, right? So what a server actually is, you've correctly said it, it's a computer. In layman terms, it's just a computer. Okay? Just know it's a computer. So, but it's a computer different from what we are using. You can use your computer as a server, but usually when we are using things like this server, we are using here we are using our local computer, but a server is a storage on someone else's computer. Okay, and these computers are collected in a way. When you have a hosted server is a local server, not on your computer. Maybe let's say companies like AOS here in Rwanda, they have servers. So what do you do? They get a big computer like ours. For instance, mine has maybe 1 terabyte GBs, okay, of storage and RAM of 16, let's say. We look into this in a few. So what they do, what a server is, okay, they take this my computer. If I'm to make it a server, I'll just break this 1 TB into different partitions. Maybe I get one for 500 GB, another one for maybe 40 GB, depending. So what they do when you want a server, when you buy a server, depending on the amount of money you pay, or depending on what you need, you go and tell them, me, I need 500 GBs on the server. So you pay. They just get a big computer, and then they split it into Dan server, Navana server, David server, all that, right? So you get access to this bigger computer. Then they manage it for you. They manage everything for you. So basically, a server is a computer. So why does this matter? Because if on a server you're given, it's like a computer, you're given storage and RAM. I'll tell you what RAM is and what this storage is. So if you saw a lot of tables and you store, if you are given 500 gigabytes, and you store tables of 510, it cannot work. So your server crashes, right? So that's why when you're creating tables, you need to be mindful of how much server you have, like what's the capacity of the server. Okay, so that is the storage on the server, this 1 TB. This RAM is the processing energy, I would say processing capacity. So when you're running something on that server, like when you're doing queries, you're consuming this RAM. So if you are running queries, each one of them taking maybe 1 GB, and so many people on your server at work, they're doing something, you might find that they are consuming all of this RAM. And then it also crashes. So that's why you need to be mindful when you're working with big tables. That's why companies need very good analysts to make sure that they know what they are doing and they will not crash the servers. Because if you want to try to process a table which is beyond 16 RAM, which consumes over 16, this is gigabytes, over gigabytes, 16 GB, the server cannot accommodate that. What happens? It crashes and everyone who is consuming the server just loses access. So a server is a computer, okay? So even the cloud, what we call cloud servers are also computers on someone else's server. Like if we do Amazon, we host something on Amazon, they give us a server. So what they do is they get a bigger computer and also give us the same like this one. But for them, so these servers are called virtual machines. It's just a machine, but you don't have it. It's on theirs. So that's why they call it a virtual machine. So they give you your storage. It's like your computer. So that's why at work, they will tell you, you cannot have access to the server. You cannot install this on the server because it is taking space, or maybe there's a risk of crashing the server. And the server usually is shared by so many people. So let's go to storage. These GBs, TBs. So in computer, we have so many storages, but I'm going to show you this. We know a hard disk drive, right? So these two are embedded in the computer, okay? So hard disk drive is this drive that we have. When you buy a computer, they tell you it is 255 GB. Okay, some have a hard disk, others have SSD. So why? So a hard disk is just a storage, but the difference is this is a magnetic storage. Okay, actually what is happening inside the computer, it is a magnet that is rotating and gives you storage in the, I think it's in the motherboard, I don't remember, but it's something that is, so this is heavy and it's bigger. So what they did, they invented the SSD, the solid state drive. So for it, it's faster than the hard disk drive. So if your computer has, if you go to buy a computer, most cases you ask, does it have SSD or HDD? And you want an SSD run computer. Why? Because this is faster compared to a magnetic, because now for it, when you're accessing it, this one, it depends on the how a magnet rotates. While SSD is just so fast. I don't know how it works exactly, but it's faster than HDD. So this is the storage. So RAM, so these are hard disk. When they say disk on disk, this is what they mean. It's stored either on HDD or SSD on your computer. Okay, give me a second, sorry. Okay, so these are the hard disk when you say 200 GBs or what. So RAM is the random access memory. For it, it is faster than all these. So it is an in memory. It is in memory. That is why usually it's lower. It's way smaller than the HDD. This can be 1 TB, and this is maybe 32 GB. But that 32 is a lot because it uses a lot of computer or computer memory. So for it, it's very fast. When something is running on RAM, it is so fast. That's why you cannot always run things on RAM. They are so fast, but it's very expensive. Why? Because if you want to run so fast, like things so fast, you will consume this 16 GB Murakokani like immediately. So that's why you cannot run all the queries in memory. So there are, why you need to know this, when you run Python, you will be seeing that there are things that are run on memory and others that are run on disk. So with disk, that is, you want to, it's slow, but you want a bigger space. For RAM, you use it when you want faster things, but it's limited on the storage. So cache is smaller than RAM. Cache, so when they say clear the cache in here, so cache is the fastest, no, it's not the fastest memory, but it's faster than all these, okay? So when something is stored in cache, you can access it in a second. For instance, when you copy something and it copies on the clipboard is the cache. You just come, copy it and paste it immediately. What if when you copy something, it goes to the disk? When you wanted to paste it, it will take like 5 seconds. It will delay a lot. But for cache, it is very expensive, and it is used to access faster things, like so fast. So you cannot use this in processing. It's rare. So when you say cache things, you cache things that do not take even like 1 GB, no. Because you want to access them very fast. For instance, on websites, when they say accept cookies, that means you want to access them every now and then. So this is just you can read about storage. I just wanted you to know that there is storage, and what we are doing now, we are running it on one or another storage. So basically, you're either running it on HDD, SSD, RAM, or cache. Not cache, by the way. Cache is, you don't run these queries on cache. Okay? Yeah, so without further ado, you can read more about this. So let's leave these 10 minutes for the quiz. And I want to thank you for these wonderful sessions with SQL. And yeah, congratulations for completing the first, not the first, this part of SQL. And I hope we'll see each other next week with Python. Fabrice, over to you.
Sorry, Fabrice. Why is it asking me to enter with an email? No, I just. Oh, okay, I sign it. Oh, I just click. Okay, enter the code. Okay, I saw it. So where is the code? Code. Let me just which code? Oh, 2939 26 1545. Me, I have joined.
Oh, why am I getting a message that I should wait for the host to start the quiz? That means I'm ready.
What? Okay, why? Okay, yeah, I can't get the question. I don't know. Yeah, I even added my name. Or if I'm using I'm using a different. But it's, yeah, I have. Yeah, it is started. It is still get ready to. Yeah, I see they like a cake. Yes.
Sorry, where are we selecting from? Because I'm still waiting for the host to start the game. On my side. No. I did that. Let's start again. Okay. 26. Yeah. I have joined and I get a message that I haven't responded to this question. There's a picture of a ball. Okay.
A big congratulations, John up.
Thank you, thank you. But who was the second? There's somebody who was really on my neck. Hey, Colette. Ah, she's really something. Congratulations to you too.
Yeah. Thank you very much. See you and have a good night.